So if someone wants to get into what you're doing now, like if there's a kid out there who's interested in birds, how would you recommend that they get started?
Well, funny you should ask, because I have a book coming out
Oh, snap.
in in in
I feel like
in,
you've done a few of these
in a
interviews.
little over a month, May 9, and it's called The Evolution of Beauty: How Darwin's Forgotten Theory of Mate Choice Shapes the Animal World and Us. And so this is really a recruitment document. It's exactly for that girl bird watcher in Wyoming, or that guy that's gotten into birds in Texas and is wondering what sort of science is available out there, right? And it's we didn't talk about it, but my ideas about aesthetic evolution are not that popular in evolutionary biology. Most people would prefer to explain away beauty as not really beautiful, but all about getting better. That's you get the female's getting good genes, or she's getting better worms, or no sexually transmitted diseases, right? And I really think that most of the time, birds are just getting what they want. That they're actually agents, aesthetic agents in their own evolution. So, creating scientific change is hard. But we have some pretty good examples. And so one of them is sort of phylogenetics, getting phylogeny back into evolutionary biology. I've been observed that. Getting people to understand that birds are dinosaurs and discovering it. Hey, that's a lot of intellectual change. So evolution of beauty is like another front in trying to create intellectual change. And a lot of that occurs through recruitment of new people. So right now, evolutionary biology has several generations of people that came into it because they read Richard Dawkins' A Selfish Gene. Right. And that's a great thing. But we need some more diverse and different kinds of people in evolutionary biology. And so that's why I wrote The Evolution of Beauty. Because I'm hoping that people go into evolutionary biology because they want to understand beauty.
Yeah, like sexual selection as a whole is so fascinating to me because it's almost, in a weird way, or at least in an unconscious way, it's almost as if like the intelligent design people that we love to rail on are like a little bit right. Like we are designed by mind, but we're designed by our own minds over evolutionary history.
Yeah, amen. I back in one of my early bird feather papers, I actually wrote that for most of the 20th century, the creationist critiques of the adaptationist theory or the aerodynamic theory of the evolution of feathers were actually right. In other words, there were no intermediates. They took apart this notion that birds had elongate scales that got longer and longer and longer, and then caught air and then flew. Which turned out to be totally false. And the creationist critique of that argument was actually correct. Now, that doesn't mean that creation is correct. The alternative wasn't that, therefore it must have been specially created. But indeed, to their discredit, I think evolutionary biologists have been struggling to avoid the reality of animal mind, and in particular, the subjective experiences of animals. There is something it is like to be a female peafowl looking at a peacock and liking it or not liking it and making a choice. And that agency, that ability to make choices, sexual choices based on what you like, has driven a huge amount of diversity in the natural world. And we're trying to explain it away rather than admit it and explain it. And so that's what the book is really about. And that's sort of an exciting thing that's going on right now in the lab.
That's really cool. And I think more generally that speaks to the fact that wherever you are, even if you think you've got the most objective science, you really want to avoid the echo chamber phenomenon, where you don't have, like, if the only people out on the fringes are very kooky people with ideas that are factually wrong, you still need those people because often they'll poke little holes in what you're doing.
Well, indeed, in science, we're interested in practical theories that work, but we often think that means we should narrow down to just one current theory, right? But in fact, in order to be a healthy discipline, we need at least some pluralism. That doesn't mean, anything goes. Obviously, a lot of ideas are ridiculous. But it does mean that the party line has a real danger. Dogmatic adherence, like this is the way, matter works. And then suddenly you got people that are on the fringes talking about dark matter or dark energy. And suddenly they go, oops, it turns out we're only describing 5% of the mass of the universe, but maybe that's the 5% we care about, but still we don't have a complete theory, right? Yeah. And so you gotta have pluralism. You gotta have some opening for diversity of thought in order to get a healthy science.
So how do you have any ways that you try to avoid that too? Because people always talk about in science how you're supposed to be constantly trying to disprove yourself, but it's very hard to get outside of your own perspective and your own pet theory in order to do that. And you see time and time again that people who are even people who are trying to actively disprove themselves end up narrowing their vision to the things that they see that confirm what they believe. So, do you have any thoughts on how you go about protecting yourself from that, or does it just take other people?
Well, I think a lot of it has to do with style of mind. What kind of thoughts and thought processes really make you go, right? We have these amazing tools and more and more technological capacity to investigate and inquire about the world, right? So the question is, how do we use them well? And I think that one of the best analogies comes from an essay by Isaiah Berlin in the mid-20th century, and he wrote a book called The Hedgehog and the Fox. And it's actually an analysis of the career of Tolstoy, but he takes up an old Greek myth or old Greek aphorism where the guy said, the fox knows many things, but the hedgehog knows one great thing. Of course, the hedgehog is an animal covered with prickles, right? And when it has a problem, it just rolls up in a ball. And he, Berlin, analyzed this as a kind of analogy for intellectual style, right? And and hedgehogs are people that burrow down into one dimension, right? Really, really, really controlling for everything and making progress. And foxes are attracted to baubles and new things, and they're diverse. They're sometimes disloyal. They'll do one thing and then a totally other thing, right? And to be healthy, science needs both foxes and hedgehogs. But the science you're describing is mostly hedgehog science, right? And so one way to avoid groupthink is to be a fox, right? And to wheel around on the question and ask it from a totally different way, right? And the fox has problems. One, it's a lot easier to tell the quality of hedgehog research, right? Because it goes along for decades. It's like, well, why did they do that? Well, they did it because this experiment said that, and then they did this because that experiment said this. But you're moving forward. The fox looks like crazy, right? It's all doing different stuff, right? But we need a lot more foxes in science, right? And they're the ones that will wheel around and disrupt the current thought and bring in something new. Right. And so I think if you're a scientist and you just say, well, I got to have some foxes in my lab, or I got to be hanging out with some foxes to make sure that my hedgehog tendencies, which are great, don't become a problem for me.
Right. Yeah. You need those people who are willing to go out into the fringes of the unknown and maybe fail catastrophically. and it's
Well,
sort of
maybe not fringes. Well, you don't want to fail catastrophically at too young an age because,
right.
there's a weeding out process. You want to stay in the game. You want to stay in the profession, right?
Yeah.
So you can't get too crazy too early. But indeed, yes, you have to seek out opportunities for at least local disruption in how you're thinking about a problem, or just pick up wholly new problems, right?
Yeah.
But right now, I'm doing collaborations with people in physics, applied physics, mechanical, chemical engineering, economics, organic chemistry, and even in the humanities, right? And so for me, one way I really like to do it is to bring new people that don't think about birds to relate to birds. Recruit people to smart folks who get interested in birds. That's a good way to do it.
That's a great. I feel like maybe there's something in 21st century science that's leaning towards that, with the fact that everyone's more networked. That if we have the ability to, and we make the choice to, we can actually all of a sudden connect all of these fields that for decades have been operating on this sort of, do a PhD and focus in and know more and more about less and less until you know everything about nothing. Get it into.
The interesting thing is that in order to have interdisciplinarity, though, you really need disciplinarity,
yeah.
right? Unless there's an engineering school with a mechanical engineer and a school that also has an evolutionary biologist interested in birds, you're not going to get those two people together. If they're at separate institutes, or we don't have departments at all, and we just say, what's the most exciting thing? What's the chance you're going to hire a bird person? Almost none, right? It's only by saying, oh, we want to have different kinds of things that represent the different disciplines that we're going to have this. So it's an interaction. How you make sure that people get out of their buildings and start to connect with others that have other intellectual interests. That's a challenge. I do it now because I'm addicted to it. I know there are smart people out there that can help me understand birds better. And so my job is to go find them and somehow bring them into relation with ornithology.
So you're internally motivated. For you, it's just that birds are intrinsically fascinating. Eh?
Yeah, I never try to justify it. It might as well be ballet or anything else. It is purely for its own sake. And yet some of the work we're doing is in bird structural color, bird feathers, blue bird feathers. We've done a lot of work on the physics of blue bird feathers. It turns out that there are a couple labs in the world now working on the next kind of color Kindle, like electronic paper.
Okay.
They're using biomimetic approaches based on the discoveries we've made in the physics of blue bird feathers. Okay, so nobody would have expected anything like that could ever really arise. And I didn't. I just wanted to know how blue bird feathers work, right? And how birds grow them. And so this kind of unexpected stuff keeps arising. So it makes you excited to go to the office.
Yeah, I think that's a scientific universal in a lot of ways. Like quantum mechanics was like that. We have computers now. Who'd have thunk? Or this CRISPR revolution, right? Is people who are really interested in how to make better bacteria to make yogurt for an industrial plant, and they stumble on this incredible discovery.
Or even more fundamentally, how does the bacteria have an immune system?
Yeah.
Within a cell, right? And it's like, well, it does this sort of business. Wow, we could actually use that in a practical way. There's a lot of unexpectedness, and that's why having disciplinary diversity will create those opportunities for interdisciplinary advance.
That's really great. I'm conscious of your time. I know you said you had to take off at 11. So thank you so much for coming on. This has been a fascinating conversation, and I want to give you, I guess, the last word if there's anything you'd really like people to know that we haven't got to do in this conversation.
Well, first of all, it's been a really great pleasure to be here. I have really enjoyed learning about your work. I thought exoplanets was a fantastic one. Pluto, CRISPR, Cas9. Your work is awesome. I'm looking forward to seeing the bird origins video. Again, I don't think you have to have grown up thinking that birds are the most important thing in the world to relate to this story about scientific discovery. And it's just one example of all the kinds of things that are available in science and in the realm of evolutionary biology that make it a really fascinating thing to study. So thanks for your interest.